Hello guys, in this video I would like to talk about details about the model for one Factor ANOVA. Before this video, I have done two videos. One was general about analysis of variance, that's why we need analysis of variance, and the second video was about the assumptions, key assumptions of analysis of variance and how we can check those assumptions to whether our data fulfill those assumptions or not. And this is the third video of this series of analysis of variance. So we will try to show a model, the data by using a model for analysis one-way analysis of variance, and then you can see on the screen we have calculated mean for each treatment, and you can say factor levels, different levels of a factor, like we have three levels for this factor, so we have calculated. So let's talk about this in this video in detail. Okay, we have done this already. So let's see, define one-way analysis of variance, because if we can represent the data by a model when we know about the data briefly up so one way refers to the fact that one way or one factor refers to the fact that the analysis considers only a single categorical variable with multiple level groups. So this is obvious now. We have when we are studying this analysis of variance in terms of one factor or one way, this means that we should check different levels of single categorical factor. There can be multiple levels, 2, 3, not 2, that can be more than 2, 4, 3, 4, 5, and so on for the categorical factor. We have example on the next slide, so you will see them, and we have an example here as well. For example, if you are studying the effect of different fertilizers on a crop field, the independent variable factor is fertilizer type, and it has multiple level, e.g. fertilizer A, B, and C. The dependent variable is crop yield, a continuous variable. So this is one of the best example. And when you are testing, another example can be soil type. If you are analyzing, the crop yield, when you have crop yield and soil type, the soil type is now independent variable, and that can have different categories like soil type A, B, C, D, and so on. So these are example of one factor analysis of variance. You can have multiple examples, not these two only. In contrast, I don't want to talk about two-way ANOVA, but I just briefly mention here that you will see what is then a two-way ANOVA or two-factor ANOVA. It's a natural question, so I just mentioned this here as well. In contrast, two-way ANOVA involves two independent variables, factors, such as fertilizer type and soil type, to examine their individual and interactive effects on the independent variable. The dependent variable, remember. So in this case, now this is fertilizer types, this is soil types. So one should be on the top of the column and with multiple levels, and the other should be with the rows and with different levels. Okay, so we can make some data like rows, then we say rows effect and column effect, because we have two variables, independent variables. So this is all about one way and two way, one factor and two factor. Now we have this problem or example, so we can explain what is meant by this actually. So look at this. Look at this. Okay, what this state: an investigator for consumer cooperative organized a study of the mileage obtainable from three different brands of gasolines using 15 identical motors set to run at the same speed. The investigator randomly assigned each brand a gasoline of 5 of the motor to 5 of the motors. Each of the motor was then run on 10 gallons of gasoline, with the total mileage obtained as follows. Okay, now understand the question. This is important. You need to understand the problem, then you can solve. This is my opinion. If you don't understand, it is impossible to solve. Oh, look at this. Gasoline level 1, gasoline level 2, and gasoline level 3. So what we said in one factor, on the previous slide, that we have a categorical variable with multiple level, categorical factor with multiple levels. So the same thing, we have this gasoline with different level, gasoline 1, 2, and 3. So now this is the perfect example for explaining one way or one factor ANOVA. Okay, so you can see that you are running motors, 5 motors with this gasoline level 1, gasoline level 2, gasoline level 3, and you obtaining total mileage. Okay, here. So now you want to test whether the mileage, the average mileage, is different for each of them, for the 3 gasoline levels or not. In this case, you are using analysis of variance and you are doing proper testing, which we will do later, not now. So this was just to explain what is mean by one factor ANOVA. Okay, now let's go to the model, which is the important part of this today lecture. In fact, that's this one. So what we do actually, we test the hypothesis whether, okay, and let's make it, oh no, okay, let's okay, do like this, it's better. Okay, now details about the model. So when you are writing dependent variable like yij, and then the overall mean is mu, and ta I is the impact of first level, ith level of the factor, like the gasoline level. So this is now the impact which can be produced, which can have by the ith level of the factor. In this example, this is gasoline 1, 2, and 3. So I mean 1, 2, and 3. Okay, and this is the epsilon ij. So this is the error terms, and the error terms has the assumption that it is distributed normally with zero mean and variance sigma square. Remember that in an analysis of variance, we assume that all population have a similar variance. If it is not exactly equal, so we say common variance unknown, common unknown variance. So yij is the dependent variable, mu is the overall mean, and ta I is the impact. This represent, you can say, the impact which can impact the mean value from the ith level of the factor which we introduced, and this is the error term. So what is now, how we can calculate the mean value? Just apply the mathematical expectation on both sides. Epsilon expected value of yij is equal to expected value of mu plus I plus epsilon ij. And now again it will remain the same on the left side. On the right side, expected value of constant is constant. Expected value of I is equal to, okay, so you can write separately in fact on this side because this is additive term. Expected value of epsilon ij. Now this is mean again mu. Ta I, you can write anything here, you can write alpha I, you can write whatever. This mean the impact. Remember that this is not remain the same. This can be a quantity, like the average quantity. Okay, and this is 0 because the assumption, you can say epsilon ij is 0 with the mean value. So the mean value, expected value mean the mean value, so that is 0. And now, so the mean value now of the dependent variable is mu plus ta I, the impact, the overall mean, and the impact from the ith level of the factor. Now we can list like this. Suppose we take this example. There are 3 levels. We can write like this. With the first level, the mean value of the dependent variable is mu plus tau 1. So this, we don't know about this tau 1. This can be some quantity. This can be negative, it can be positive, whatever. Epsilon expected value of second level with the dependent variable part, the second level of the second level of the factor, that is x2, tar2. So that is equal to mu plus tar2. Tar2 can be negative or positive, whatever can affect the mean values can be less than the actual mean, like the overall mean, or if it is negative, then this is less than the actual mean. If it is positive, this then the mean value of e y2j can be greater, and in case of negative tar2, the mean value of y2j can be less than the overall mean. Similarly, you can calculate third level of the factor, impact of the third level of the factor on the overall mean. E expected value of y3j is equal to mu plus the impact from the third level of the factor. Therefore, we can say that the mean values of all treatment are not equal when tau1 is not equal to 0, tau2 not equal to 0, tau3 not equal to 0. So when these quantities are not equal to 0, this means that the mean will be affected by the first factor in one way, the second factor in other way, and the third factor in other way. So we can say that the mean values are not equal in this case. So this is all about what we know about one factor ANOVA. What are the details of the model for one factor ANOVA? So we will do hypothesis testing in the coming lectures. So I think this is enough for today. This about detail about the model for one factor ANOVA. And so when you know these basics, then that will be easy for us to formulate the hypothesis and do the rest of the procedure for hypothesis testing. So I think this is enough for today, and in the next video. Ciao.